This is Lecture 11, Part 7, focusing on gums, also known as hydrocolloids. These are the non-glucosidic polysaccharides. There are a number of reasons that gums may be used as a food ingredient. They influence texture and mouthfeel. They can bind or at least manage water. They stabilize crystallization properties in products such as confections and ice cream. They control distribution of particles in a solution or dispersion. And finally, they can form a 3D network, or a gel. Gums come from a number of different sources, and the source influences the final functional properties. Seed gums include guar and locust bean. Locust bean actually comes from the seed of the carob plant and is used as a thickener in cream cheese and condiments and ice cream. Guar is unique because it does not need to be heated in order to form a gel, and it has good freeze-thaw stability, making it well suited for those types of products in which that is an important characteristic. Tree exudates is another way of simply saying tree sap. The sap hardens as it oozes from the tree, and the hardened sap is collected and ground into a fine powder, which is the gum. Each has unique characteristics that determines how it's used. Gum arabic is used extensively in flavor emulsions. You'll find it in nearly all soft drinks. Chorea is most commonly used not in a food product, but rather to hold in your dentures so you can, in fact, eat that food product. Marine gums are derived from seaweed. Again, different seaweeds are used, resulting in different characteristics. Carnelian is extracted from red seaweed, and this is a product that's sometimes called vegetarian gelatin. For carnelian alone, there are 3 different classes that have different functional characteristics. While many of us think of gums as being a relatively new product in foods, carnelian is a good example of why that is not the case. It has been used in Ireland since 400 AD, in China since 600 BC as an ingredient in food products. Microbial fermentation, bacteria specifically, are also sources of gums. Xanthine and gellan are examples of gums from this source. These 2 gums are used extensively in salad dressings. Chemically altered gums, in most cases, start out as cellulose prior to treatment. Carboxymethylcellulose is probably the most common. Gums are long-chain, 2,000 to 10,000 monosaccharide units. They can be straight-chained or branched. Galactose is a common constituent, but usually there are at least 2 sugars or sugar derivatives present. Glucose is just not one of them. Structurally, they contain a lot of hydroxyl groups, and that means they can bind or control water. So what determines a particular gum's characteristics? First, the type and number of monosaccharides present. This influences viscosity and hydration rate. If the structure of the gum is highly branched, it will occupy less space than would be the case if it were straight chained with the same molecular weight. That means it will provide less viscosity. On the other hand, longer length means greater volume because there's more interactions and therefore more viscosity. This is known as DP, or degree of polymerization. Secondly, Configuration of the monosaccharides present. Are they alpha or beta? This, of course, refers to the position of the hydroxyl group at the number 1 carbon of a monosaccharide. Is it located above or below the ring? Below is alpha, above is beta. And finally, the number and location of linked groups. This is referred to as DS, or degree of substitution. Degree of substitution refers to the number of side units per unit length of the monosaccharide chain. The greater the number, the more spread out, and therefore the greater the ability to hydrate in a short time period. If those side units are charged, then they repulse each other, and the chains tend to elongate, which in turn increases viscosity. If the side units are very uniformly spaced, then you have a gum that is cold water soluble. What are the benefits of using gums rather than alternative ingredients? The alternative to gums typically is starch. A major benefit is the lack of a starchy mouthfeel, while retaining the ability to thicken a product. Starch is also well known for flavor masking. When gums are substituted, you get better flavor release. That is due in part to the lower levels of use. 0.05 to 1% of the product weight, as opposed to 0.75 to 10% of the product weight when starch is used. Gums also result in thinner process viscosity, and this is especially important when processing at higher temperatures. Why? You get better heat transfer, easier pumping, and more accurate filling of containers, all of which are a concern in food processing. Shelf life extension, primarily due to the ability to bind or control water, is another characteristic of gums. This is imported in breads and cakes, which are softer for longer periods of time. It's also imported in tortillas, which result in a more pliable product. Gums can also be emulsifiers, and they are true emulsifiers, not just thickeners. They have hydrophilic and lipophilic ends, just like traditional emulsifiers. Indeed, this is a key role that gum arabic plays in many products. From a nutrition perspective, gums are a source of dietary fiber and little else. So that makes them particularly friendly in the formation of diet foods. In addition, they're generally non-allergenic, with one exception, gum tragacanth. And they can be used in gluten-free products to aid in producing a bread with characteristics similar to that made with wheat flour. It is the gums that replace the elasticity that would be contributed by the gluten. Xanthane and guar are commonly used for this particular purpose, and they are both readily available in the consumer marketplace. Choosing a particular gum depends on two factors: the functional properties that you want in the final product, and the ability of the gum to stand up to processing conditions. So let's quickly summarize those functional roles and identify products in which they are used for that purpose. Gums are used because they are thickeners. That is important in sauces, beverages, soups. Gums are used in reduced fat baked products because they are humectants. they physically bind water, extending shelf life. Gums are also used when you need a thermo-reversible gel. This is a gel that melts with heat and is characteristic of water or dairy-based gel desserts, canned meats like ham, and some confections. Gums are also used when you want non-thermo-reversible gels. In this case, the gel structure is retained even with heat. Uses include jams and jellies, gelled confectionery products, and restructured meat products. Finally, gums are used when cling is important. A good example of cling is when salad dressing stays on the lettuce as opposed to pooling in the bottom of your salad bowl. This is a function of adhesion and occurs because a gel has reformed. Salad dressings often start out as a gel, which, because it has a yield point, will pour from the bottle as a sol, and then reform as a gel on the lettuce or other salad ingredient. Functional characteristics of gums can be affected by acids, enzymes, and heat. It is also important to remember that gums tend to be water organizing rather than binding, so they have no effect on water activity.